Let's talk about solving absolute value equations. The absolute value of a particular number is the distance from that number to 0 on the number line. And distances are always written as positive values, so if you take the absolute value of 4, you get 4. But if you take the absolute value of negative 4, you still get 4, because there's 4 units between 4 and 0, and there's 4 units on the number line between negative 4 and 0, okay? So showing you on the number line here, there's 0, and then positive 4 would be 1, 2, 3, 4 units to the right. Negative 4 would be 1, 2, 3, 4 units to the left, okay? So that's why we get the same answer for either the absolute value of positive 4 or the absolute value of negative 4. It's important to keep that in mind when you're trying to solve absolute value equations, okay? Because what we're going to be looking for is what values could x be inside the absolute value bars, so that we get that one specific value once we take the absolute value of whatever's inside the absolute value bars, okay? So let's take a look at a real simple example first. In this example, we just want to solve the absolute value of x is equal to 5. Okay, this is just kind of get you comfortable with the notation that we're using with these particular types of equations. First thing that you're going to do is you're going to make sure that the absolute value is set on one side of the equation by itself, and I'll give you these steps again in just a minute. We have that here already. We don't have to move anything around. The second step is going to be to make sure that the equation itself can be solved. Absolute value can only ever give you either a 0 or a positive value. So your constant that we see here set equal to the absolute value will need to either be 0 or a positive number, which we also have. Okay? The next step is to create two equations. One, to find out what x would give us the positive of the constant that we have. And then another one to find out what x would give us the negative of that particular constant. Because we're doing absolute value, the absolute value of positive 5 is going to give you 5, and the absolute value of negative 5 will also give you 5. Okay, so we wind up with two answers here, and of course, if your equation's a little bit more complex, you may have some more steps to do once you get to this point. But for this one, we're done. Okay, x is going to be equal to either 5 or negative 5. Now you'll see this sometimes written with a set of braces to kind of put those two values together in the solution set, or you may see it without the braces, one of the two. On WebAssign, you'll just type the answers in. You'll need a comma between them, like I've got between the 5 and the negative 5, but you will not need the braces. Okay? All right, let's move on to a little bit more complicated example. And I tell you what, before we actually do that, I'll give you the steps. Okay, our first step is to isolate the absolute value. You want it on one side by itself. The second step is make sure the equation can actually be solved. An absolute value equation must be equal to either 0 or a positive value. So if you get a negative number, you're going to wind up with a situation where you can't find a solution. So those will be called our no solution cases. The next step is to drop the absolute value bars and make two equations. Our last step will be to solve each equation. So let's take a look at a fairly simple example, a little bit more complex than the one we did just a second ago. I'm going to scoot these steps up just a little bit so I've got a little bit more room down here. And let's say that we have the absolute value of x plus 4 is equal to 2. Okay? In the first step, we want to isolate the absolute value, get it by itself on one side, and we have that already done here. We have the x plus 4 inside the absolute value bars already isolated. The second step is to make sure that the equation can be solved. You want to analyze the equation and check to see if you can actually work it. What that means is you need to look at the constant that you have on one side of the equation and decide if it's equal to 0 or a positive value. We do have that here, so we can proceed on with the third step. You want to drop the absolute value bars and make two equations. One equation for what if the number inside the absolute value bars is a 2, and then one for what if the number inside the absolute value bars comes out to be -2. Okay, so this is going to give you two answers, two values for x, that we'll be able to plug in and find that they do work for this particular equation. All right, now to solve each one of the little equations that you've created, we'll need to subtract 4 from both sides. So x is going to be equal to 2 minus 4. And then subtract 4 again over here. X is going to be equal to -2 minus 4. That's -6. So a -2 and a -6 are our two answers. And again, in WebAssign, you'll need to write those together. They don't have to be in numerical order, but they will need to be separated by a comma. And that's your answer. All right, let's try another one. This time for this example, let's take, sorry, wrong color. Let's take x plus 6 is equal to -2. Okay, now this time we do the first step and make sure that the absolute value is isolated on one side of the equation, which it already is. Then the next step is to analyze the equation and decide if it actually can be worked. So if we look at this one, this time our absolute value, the absolute value of x plus 6, is set equal to a negative number. It's not 0 and it's not a positive number. So we actually can't work this one, okay? This is one of the no solution cases, so it's very important that you remember that if the absolute value is equal to a negative number, you can't work it, okay? So no solution will be our answer there. All right, let's try another one. This time maybe a little bit more complex. 2x minus 5 inside the absolute value bars is equal to 3. Okay, so your first item is that the absolute value is isolated, which it is. Your second item is to make sure you can actually work the problem. The constant that we have is a positive 3, so we're okay there as well. And then the next step is to break it up into two, or create two equations. So the first equation, what would x be if 2x minus 5 is equal to positive 3? And then what is x going to be if 2x minus 5 is going to be equal to -3? Then go ahead and solve each one of these two separately. So add 5 to both sides. 2x is equal to 8. So 8 is 4. 8 divided by 2. And then 2x is equal to, if we add 5 to both sides here, we're going to get a 2. Divide both sides by 2, and x is equal to 1. So our two solutions here are 4 and 1. Okay, let's try another one. This time we'll put something outside the absolute value bars so that we'll actually have one that does have something that we need to move in the first step. Okay, now your very first step is to move anything that is being added or subtracted to the absolute value. We want to isolate the absolute value completely. So let's separate, or let's subtract 7 from both sides with the absolute value of x minus 8 is equal to 5 minus 7. gives me a negative 2. And now if you analyze it, you'll notice that it is equal to a negative number, so we cannot finish the problem. We will not come up with a solution for x, so this has no solution. Okay, now if you had analyzed first and then moved the number, you might be in trouble, because if you had analyzed as the first step, the constant that's on one side of the equal signs is a positive 5. And then once we move the 7, we wind up getting a negative value. So it's really important that you keep those two steps in the right order. Be sure you isolate the absolute value before you do anything else, before you decide whether or not you can work the problem, okay? Alright, so that gives you a few absolute value equations to look at. Also lets you know what's going to happen with the negative number on one side as the constant. Let me show you one more thing. This is another situation that might be considered sort of a special case, like the no solution. You do get an answer with this one. When you have absolute value set equal to a 0, let's say I've got the absolute value of 3x minus 1 is equal to 0. You still check, you still isolate the absolute value first. You check to make sure the problem will work, and we are set equal to 0, so that's perfectly fine. Then, when you go to split the two equations up, let's look at what happens. We get 3x minus 1 is equal to 0. And then when we go to make a second equation, we still get 3x minus 1 is equal to 0. Because remember, 0 is sign neutral. It's neither positive nor negative, so we actually don't get two different equations, all right? So if you're set equal to 0, you don't have to work two separate equations. You can just work one of the two, and that gives you the only answer you'll get. So you'll only get one answer instead of two for this type of equation. And we find that our x is equal to 1/3. And plug that back in and check it. On any of these, you can check by plugging the numbers back into the original problem. All right, so that's going to conclude our little video on absolute value, and that finishes out our section 1.1.